This video is about finding least common denominators, also known as LCDs, least common denominator. But before we can talk about a least common denominator, we have to understand what a least common multiple is. And a least common multiple is the smallest multiple that two or more numbers have in common. So before we can understand that, we have to know what a multiple is. A multiple is created by multiplying a number by the counting numbers. Now recall that counting numbers are the numbers that we use to count with. We count 1, 2, 3, 4, so on and so forth things. So those would be the counting numbers. So we'll practice that. Let's find the multiples of 4. 4 times 1, that's 4. 4 times 2, that's 8. 4 times 3, that's 12. 4 times 4, that's 16. 4 times 5, that's 20. 4 times 6, that's 24. 4 times 7 is 28. 4 times 8, that's 32. So we have in 4, 8, 12, 16, 20, 24, 28, and 32 the multiples of 4. Now this is not all of the multiples of 4. I can keep going obviously, but that is a partial list of the multiples of 4. And these over here that I've highlighted here, these are the counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. And again, that would keep going as well. So now let's talk about finding the least common multiple of 4 and 10. So first of all, we're going to find the multiples of each of these. So 4's multiples, we already have a list of those, 4, 8, 12, 16, 20, 24, 28, so on and so forth. 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30, 10 times 4 is 40, 10 times 5 is 50, so on and so forth. So now we're going to start at the low end, and we're going to look for the smallest, the least multiple that both have in common. So that's what we're looking for, the smallest multiple in common. So 4, no. 8, no. 12, no. 16, no. Oh, wait, here's one, 20. So that's where we see that our least common multiple is 20. And that's how we find least common multiples. Now something that a lot of students get it confused on is the fact that a least common multiple is not necessarily a small number. So least common multiples are not small. The smallest a least common multiple can be is actually the bigger number, because multiples explode out, and so the multiples of 10, they can't get any smaller than 10 itself. And so if they were to be in common, nothing smaller than 10 here means that our least common multiple can't be any smaller than 10. So don't make that confusion that a least common multiple is going to be a small number because it has the word least in its name. All right, the next thing is we want to talk about another way to find these least common multiples, because that method of finding a least common multiple by listing out all the multiples of the numbers gets very, very tiresome, especially when those least common multiples end up being really large numbers. So this is an easier way. It's using our prime factors. So what we're going to do is prime factorization on both of our numbers. So let's again find the least common multiple of 4 and 10. So I'm going to find the prime factors of 4. 4 is 2 times 2, and I'm going to write that with exponential notation, right? 2 is my base. It's been used, it's the factor that's repeatedly multiplied. How many times it's been multiplied? 2. Now the next one, 10. 10 is 2 times 5, so that's just 2 times 5. And remember that these could be written with exponents, and if we did, those exponents would be 1. Now after we find the prime factorization, our next step is to find the unique factors with their highest exponent. So here are our factors, 2 squared and 2 times 5. So I have 2's and I have 5's. 2's and 5's are unique. So my least common multiple is going to be a product of 2's and 5's. So 2 to what power is what I need to know, and 5 to what power is what I need to know. So I'm going to look for my highest exponent. In the 2's, I have a 2 squared, or I have a 2 to the first power. And you see that the 2 squared is the highest exponent. So that's going to go in my exponent here. And the 5's, there's just to the first power, so that's the first power, and it's going to go here. So you see my least common multiple is 2 squared times 5 to the first power. 2 squared is 4 times 5, which is 20. And you again see my least common multiple being 20. The same thing we got before. Just an easier way. Now I want to show you that there is another way to look at finding a least common multiple that doesn't require exponential notation. So this is how this goes. What you do is you write out your two numbers that you wish to find the prime factors for. Then you write out your prime numbers that are unique, right? So which prime numbers did you find in the factorizations of each of your numbers? And then you just write out the prime number factors. So 4 is just 2 times 2. So I'm going to write 2 times 2 in the box that tells me the prime factors in 4. And then 10 is 2 times 5. So I'm going to write 1, 2 in the 2 box and 1, 5 in the 5 box here. And you see as we multiply across in the 4 row, we see 2 times 2, which is 4. And in the 10 row, 2 times 5, which is 10. Now, the key is that using this method, we can only circle one box per column. So prime factors, you take the highest exponent, right? So prime factors, which are 2's and 5's, I'm taking the highest factors by circling the box with the most factors. So I'm going to circle the box with 2 2's versus the one with just one, right? Highest 2 2's. And this one doesn't have any 5's, and this one has 1, so I'm going to circle this one here. And then we write out these circled boxes to get our LCD or LCM again, 2 times 2 times 5, which is 20. Now, an LCD is an LCM. LCD stands for least common denominator. So the LCD is the LCM of the denominators of fractions. So if I had 1/4 and 1/10, the LCD of 1/4 and 1/10, the LCD, is just the LCM of those denominators, 4 and 10. And we know that the least common denominator, or least common multiple of 4 and 10 was 20. So the least common denominator of 1/4 and 1/10 is 20. Now let's actually have you try this. So I want you to find the least common multiple for 18 and 24. So why don't you pause your video and go ahead and give that a try. Okay, so hopefully you have actually given it a try. So let's start here. Here's my 18, and here's my 24, and I'm going to do the prime factorization for each. 18 is 2 times 9. 2 is prime, so I circle it. 9 can be broken down further. It's 3 times 3. So I circle those. And so this means 18 is 2 times 3 squared, because there are two factors of 3. Now 24, I can start anywhere I want. Remember, it's nice to start with the lowest primes, but it's not necessary. So I know 4 times 6 is 24. 4 is factorable as 2 times 2. 2 and 2 are both primes, so I circle them. 6 is factorable. It's 2 times 3. So I'll circle both of those since how they're prime as well. And now I can rewrite this as 2 to the third power, because there are 3 factors of 2, times 3. Now, in finding the least common multiple, I'm going to take a look here and I'm going to see, okay, what do I have? Well, I see 2's and 3's, also 2's and 3's. So my least common multiple is going to be made up of 2's multiplied by 3's, and now I'm looking for highest exponents. On the 2 here there's a 1, on the 2 here there's a 3. The highest one is 3. On the 3's, here there's a 2, here's a 1, so the highest is a 2. So 2 cubed, 2 times 2 times 2 times 2 is 8, and 3 squared, 3 times 3 is 9. So this says 8 times 9. So the least common multiple of 18 and 24 is 72. Not a small number, is it? Remember, not small numbers. The smallest this one could be would be what? Did you say 24? Remember, it can't get any smaller than 24 because multiples, that's where what these are based upon. So the multiples of 24 start out with 24. Well, there's not going to be anything lower in common, so 24 would be the smallest of the possibilities. And what about the LCD for 5/18 and 7/24? What would that be? Did you say that the least common denominator of 18 and 24 is also 72? Because the least common denominator is the same thing as the least common multiple for these denominators. So that's the least common denominator. Now you know how to find a least common denominator. Now we can put that knowledge to use in order to add fractions that don't have like denominators, and that's why we need this skill.